Hello, my name is Overholt, and the topic I'm going to be covering today is Common Core in the California school system. The topics that I'm going to be covering are what is Common Core, examples of Common Core, math examples, California's academic performance before and after Common Core was initiated, explaining the data, and then my own conclusions. California's Common Core standards, according to corestandards.org, is a set of high-quality academic standards in mathematics and English language that is supposed to ensure that all students graduate from high school with the skills and knowledge necessary to succeed in college, career, and life, regardless of where they live. The curriculum of Common Core was supposed to be a nationwide standard designed to increase performance in math and English. Before Common Core, many states had their own standards, which varied from state to state. But today, I'm only going to be focusing on California, and more specifically, mathematics in the state. California adopted Common Core standards in mathematics in August of 2010, but it was not fully implemented until January 2013. California Common Core state standards in mathematics replaced the 1997 statewide mathematics academic standards, which had been largely written by the faculty mathematics department at Stanford University. Some of the core math standard concepts in math involve reasoning and explaining, modeling and using tools, seeing structure and generalization, and then being able to attend to precision. Now that all sounds great, but compared to previous standards, I believe kids are having more difficulties adjusting and improving overall than before. Now what I have up on the screen is actually the first grade standards. As you can see at a first glance, they seem somewhat, as you can see, at first glance, the standards seem somewhat understandable, but let's dive into some with examples. What I'm going to be focusing on is the decomposing a number leading to a 10. So now I'm going to do an example. So let's take, for example, 29 plus 17. The old method meant that you were supposed to carry the 1, so you still solve that, and end up with 46. The new method that they want you to do, they want you to break this down into tens. So it becomes 20 plus 9, 10 plus 7. So 10 plus 20 is 30. And they're still having you add 9 and 7, which is 16. And then they further want you to break this down into 10 plus 6, which you add both the 30 and the 10, which is 40, plus 6 equals 46. So compared to the 2 steps required here, you're now using 1, 2, 3, 4, 5 to 6 steps to solve this problem. And that doesn't include the picture graphs that they want you to use as well. So this next slide shows the example that I just used. They want you to be able to put in picture form these numbers. Now this is all fine and dandy, but if you have a huge number, how is a kid in first grade going to be able to break that down? They're going to spend a majority of their time trying to solve this one problem when I solved it in less than 5 seconds, 10 seconds. And then they want you to describe why your answer is correct. So another example I'm going to show you, and I'm not going to go through, is they want you to subtract, and this is actually from a school textbook, subtract 38 from 25 by counting up. First of all, that concept for first graders, I would imagine, is very hard to grasp. But just to go into detail, 38 you want to count 2, from there you get 40, and then count up to the nearest, and then you're supposed to end up with 287. This is confusing just looking at it at first glance. You actually have to take the time to realize, break down each step. So imagine trying to explain that to a first grader, how complicated that's going to be. Now, Lev Vygotsky viewed interaction with peers as an effective way of developing skills and strategies. He suggested that teachers use cooperative learning exercises where less competent children develop with the help from more skillful peers within the zone of proximal development. Scaffolding is a key feature of effective teaching where the adult can continually adjust the level of his or her help in response to the learner's level or performance. Now, the problem with Common Core is it's a one-size-fits-all approach. It doesn't focus on where each child is, but keeps those who might excel in math at the same level as those who might struggle. So in terms of Vygotsky's view, Common Core falls in both zone of proximal development and scaffolding, and I believe the next slide will prove this. One way academic performance is measured is the level of enrollment in algebra level classes in grade 8, such as the graph shows. As you can see, in 1999, all the way up to around 2013, 2012, there's a still steady increase in the amount of students enrolling in algebra courses. Now, in 2013, when Common Core was initiated, you see a drastic decline, and Common Core is still initiated. So we're almost back to 1999 levels, but more like 2000. Now the next graph that I'm going to be showing shows the demographics breakdown. As you can see on the bottom, during the 1997 standards, they're ranging around 50-55% on average between all the categories: white, black, Hispanic, Asian. In the Common Core period, you can see 2015-2017, it's almost reduced by almost half. So, in conclusion, as you can see from the graphs, California's academic performance has started to drop exponentially. I have spoke to several teachers about Common Core. For example, my son used to struggle with math concepts being taught until I started teaching him the way I learned. After that, his scores significantly increased. Even during a recent parent-teacher conference, my son's teacher specifically made a point in telling us that she appreciated us teaching him the old method and could tell that the impact it was having. Other teachers I have spoke from the Etiwanda School District, who have been teachers from before Common Core was implemented, have stated that many students are not at the level they need to be because they are still struggling to grasp basic concepts. This leaves teachers to try to review or supplement additional lessons to get students to where they need to be, but teachers only have a small time frame to do that. In conclusion, the 1997 standards seem to be better prepare students for college than the current system of Common Core. A teacher I spoke to stated that Common Core, almost 75% of the curriculum had to be changed to meet the new standards. In 2006, the Thomas B. Fordham Foundation looked at state curriculum content standards across the country, and its reviewers gave California 1997 math standards a grade A, saying, and I quote, "The Golden State standards avoided almost all the pitfalls of other states. They called for the use of calculators at the right time and in the right way. The standards do not allow the use of calculators all throughout kindergarten to grade 11 and builds students' skills in a logical progression that emphasizes computation, problem solving, and mathematical reasoning all the way through. In all, the state has a top-notch blueprint for mathematical excellence." So the question must be asked, why did we move from Common Core in the first place? And should we go back to 1997 standards, considering all the evidence that supports Common Core's failure to educate our young students? This concludes my presentation of Common Core. I had more information to give, but it would have increased the time of this presentation exponentially. I thank you for the time, and these are my references. Thank you very much.